Let's take a look at some gas solutions. So we can get some gases to dissolve in liquids. It's not very easy to do though. So if we have our nonpolar gases, or almost nonpolar, these guys are gases because they don't have very strong intermolecular forces. So it doesn't take a lot of energy to break those tethers holding the molecules together. And so at room temperature, they're already at their or above their boiling points. So they are gases. It's hard to get them to dissolve, especially in water, because we don't have very good forces between the solute and the solvent, but we are able to sometimes kind of force the issue a little bit. If you've ever had a can of soda, all right, you have encountered a solution of a gas in a liquid. Now, as soon as we open that can of soda, though, now all that gas starts to be released. Our sodas are at high pressure. So the way to get a gas to dissolve is to increase the pressure. So gases are more soluble at a high pressure. They are less soluble at high temperature. Okay, so it's pressure that gives us the ability to force a gas to dissolve into a solution. Okay, so when we look at our gas solubility, you can see the temperature effect. As I raise the temperature of water, but keep the pressure the same, I go from 0.348 grams per 100 mil for my solubility of carbon dioxide all the way down to 0.058. So I decrease it by an order of magnitude just by going up 60 degrees. However, when I look at pressure, when I go from 1 atmosphere to 2 atmospheres and 2 atmospheres to 3 atmospheres, that's where I greatly increase the solubility of my carbon dioxide. So there's this law called Henry's law, where the solubility of a gas is directly proportional to the partial pressure of the gas above the solution. And so whenever you dissolve some gas into solution, you're always going to have a little bit of that gas floating around above the solution. And so Henry's law lets us relate that pressure and the solubility. Every single gas is going to have its own unique Henry's law constant. And so this right here, the K sub H, this is the Henry's law constant. Okay, and so that lets us figure out our solubility. Okay, so we've got some carbon dioxide that's inside a bottle of cola at 4 atmospheres and 25 degrees Celsius. We want to know what our solubility of our carbon dioxide is, and we have a Henry's law constant for our carbon dioxide there. Okay, and so what we're trying to figure out, okay, is, okay, what is our solubility here? Okay, and so let's see here. We can take, we've got our solubility of our gas is equal to our Henry's law constant times the partial pressure of our gas. Okay, so when we go to solve this, okay, we have our 3.3 times 10 to the negative 2 moles over a liter times atmosphere times our 4 atmospheres. Okay, and so atmospheres and atmospheres are going to cancel out, and so we take our 3.3 times 10 to the negative 2 times our 4, and we get 0.0132, and we get moles per liter. Okay, now that moles per liter, this is a really, really common concentration term in chemistry. Moles per liter is what we call this capital M molarity. And so we use molarity all the time in chemistry. It is our main unit of concentration. We have other units of concentration, but it's our main unit of concentration. Okay, so that is what we deal with gases in liquids.